Good day, learners. Today we are going to discuss 6 trigonometric functions. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos.
Dos, tres, cuatro.
In this video lesson, we are going to discuss now finding the trigonometric functions of a certain angle given a point on Cartesian coordinate plane. The radius of a unit circle is 1. Consider the origin-centered unit circle shown below, together with the angle theta in standard position drawn on the same coordinate plane. The initial side of an angle intersects the circle at point 1 and 0, and the terminal side intersect the circle at the point x and y. So as what you can see in our illustration, this is the initial side whose intersect at the unit circle coordinate 1 and 0, and this is our terminal side whose intersect at the unit circle at point P with coordinate x and y. As we are going to draw a vertical line from this particular point where the terminal side and the unit circle intersect, going to the x-axis to create a right triangle. And these two sides are the legs of the triangle labeled as x and y, and the radius become the hypotenuse of the right triangle. If theta is an angle in standard position, and if coordinate x and y is any point other than the origin on the terminal side of angle theta, then sine theta is equal to y over r, cosine theta is equal to x over r, tan theta is equal to y over x, cosecant theta is equal to r over y, secant theta is equal to r over x, and cotangent theta is equal to x over y, where the radius is equal to the square root of x squared plus y squared from the Pythagorean theorem. Example number 1. Find the 6th trigonometric function of an angle theta in standard position if point P having a coordinate of 3 and negative 4 is on its terminal side. So as we are going to plot now point P, so this is now the location of point P on Cartesian coordinate plane. As we are going to create now an angle in standard position, so this is now the angle theta. So how are we going to find out the 6th trigonometric function of this particular angle? So first thing we need to do is we are going to identify now the coordinate x and y. Since now point P is the given point, that is our coordinate x and y, which is the coordinate 3 and negative 4. So we are going to let now x be equal to 3 and y be equal to negative 4. So first thing is we have to solve for r using the Pythagorean theorem. So we already simplified now r equal to the square root of x squared plus y squared. So all we need to do is we are going to substitute the value of the x, which is 3, and the value of the y, which is negative 4, to our equation. So we have now r, or the radius, is equal to the square root of 3 squared plus negative 4 squared. So as we are going to simplify now, 3 squared is equal to 9, and negative 4 squared is equal to positive 16. So sum up now 9 and 16, that is equal to 25. So we have now r is equal to the square root of 25. So the square root of 25 is 5. So as what you can recall, or as what you can remember, square root of 5 is equal to positive and negative 5. But we only get now positive 5. Why? Because always remember that radius is always positive. There is no such thing as negative radius. That is why we get now positive 5 for our r. Next step is we need to substitute on the values of x is equal to 3, y is equal to negative 4, and our r, which is equal to 5, to our 6 trigonometric function ratios. These are the 6 trigonometric function ratios. As we are going to find the sine theta, substitute the value of y, which is negative 4, and the value of our r, which is equal to 5. So sine theta, we have now negative 4 over 5. As we're going to substitute the value for the x and the r, we have now 3/5. For the tan theta, as we're going to substitute the value for the y and x, we have now negative 4 over 3. And for the cosecant theta, as we are going to substitute the value for the r and the y, so we have now 5 over negative 4. For the secant theta, so substitute the value for the r and the x, we have 5 over 3. And for cotangent, which is y over x, that is equal to 3 over negative 4. So as we are going to simplify further, so negative 4 divided by 5, that is equal to negative 4/5. So sine theta is equal to negative 4/5. And cosine theta is equal to 3/5. And for the tangent theta, as we are going to divide negative 4 divided by 3, so tangent theta is equal to negative 4/3. For the cosecant theta, so as we are going to divide 5 divided by negative 4, so cosecant theta is equal to negative 5/4. And secant theta is equal to 5/3. For cotangent theta, as we are going to divide 3 divided by negative 4, cotangent theta is equal to negative 3/4. Example number 2. Find the 6 trigonometric function of an angle theta in standard position if point P has a coordinate of negative 3 and negative 6 is on its terminal side. So as we are going to plot now coordinate negative 3 and negative 6, so this is now the location of the point P on Cartesian coordinate plane. So as we are going to create an angle theta from this particular point in standard position, so this is now our angle theta. So what we are going to do is we are going to identify now the coordinate x and y. So since now the given point is coordinate negative 3 and negative 6, so that will be our coordinate x and y. So we are going to let now x be negative 3 and y be negative 6. So first thing we need to do is we are going to solve for r using the Pythagorean theorem. So we already simplified r, which is equal to the square root of x squared plus y squared. So let us now substitute the value of the x, which is negative 3, and the value for the y, which is negative 6. So we have r is equal to the square root of negative 3 squared plus negative 6 squared. So simplifying further, so the square of negative 3 is equal to 9, and the square of negative 6 is equal to positive 36. So r is equal to the square root of 45. But we cannot get the exact value of square root of 45, but we can simplify square root of 5 by getting the factor of 45, which has a perfect square. And we all know that 45 has a factor of 9 times 5, in which 9 is a perfect square. Okay, so square root of 45 now becomes square root of 9 times 5. So applying the rule of the radical, so square root of 9 times 5 becomes square root of 9 times square root of 5, in which we can get now the exact value of square root of 9, which is equal to 3. So we can say the simplified form of the square root of 45 is equal to 3 square root of 5. Next is, we are going to substitute the value for the x, which is equal to negative 3, and the value for y, which is equal to negative 6, and the value for our r, which is equal to 3 square root of 5, to our 6 trigonometric function ratios. So these are the 6 trigonometric function ratios. Substitute the value for the y and r to find sine theta. So we have now negative 6 divided by 3 square root of 5. To find the value for the cosine theta, substitute the value for the x and the r. So we have negative 3 over 3 square root of 5. To find the value for the tangent theta, substitute the value for the y and the x. So we have negative 6 over negative 3. For the cosecant theta, substitute the value for the r and the y, which is 3 square root of 5 divided by negative 6. For the secant theta, substitute the value for the r and the x, which is equal to 3 square root of 5 over negative 3. And lastly, for the cotangent, substitute the value for the y and the x. So we have negative 3 divided by negative 6. So as we are going to simplify all of this one, because this can be simplified into a lowest term. So let's start with the sine theta. So try to look at the whole number in the numerator and the denominator. So as what you can see, negative 6 and 3 has a common factor of 3. So we can now simplify it as 1 into negative 2 over square root of 5y, because 3 divided by 3, that is equal to 1. So we have now 1 times square root of 5, that becomes square root of 5. For negative 6, so as we're going to divide it by 3, so negative 6 divided by 3, that is equal to negative 2. For the cosine, so the negative 3 in the numerator and the positive 3 in the denominator can be simplified. So their greatest common factor is 3. So negative 3 divided by 3, that is equal to negative 1, and 3 divided by 3, that is equal to 1. So as we're going to multiply 1 to the square root of 5, that is equal to square root of 5. For the tangent theta, so as we are going to simplify now, negative 6 divided by negative 3, that is equal to positive 2. For the cosecant theta, so try to look at now the whole number in the numerator and denominator. So the greatest common factor is 3. So as we're going to divide 3 divided by 3, that is equal to 1. So multiply now 1 to the square root of 5. That is why we have square root of 5. For the negative 6, so divide it by 3. Negative 6 divided by 3, that is equal to negative 2. For the second theta, we have 3 square root of 5 over negative 3. So in the numerator and denominator, so as we're going to divide, that is equal to negative square root of 5. For the cotangent, so as we're going to divide now, negative 3 divided by negative 6. So we cannot divide exactly negative 3 by negative 6, but we can now simplify. So but remember, negative divided by negative is always positive. So 3 and 6 has a greatest common factor of 3. Then we're going to divide it into the numerator and denominator. So we have now 1/2. And then try to look at now the sum of the ratios in the 6 trigonometric functions. So there are ratios that has denominator of a radical, in which we have to rationalize the denominator. So it means that in denominator there should be no radical number. So what we are going to do is we're going to rationalize the denominator. For example, in the sine theta, so that is negative 2 over square root of 5. So we are going to rationalize the denominator by multiplying the numerator and denominator by square root of 5, which is this one, the radical in the denominator. So as we are going to multiply negative 2 by square root of 5, and also the square root of 5 times its sub square root of 5, that is equal to 2 square root of 5 over 5. So it means So negative 2 over square root of 5, as we are going to rationalize the denominator, that is equal to negative 2 square root of 5 over 5. Okay, and next we have now the negative 1 over square root of 5. So we're going to rationalize the denominator square root of 5. Okay, there is a shortcut method in rationalizing the denominators. All you need to do is identify the radical in the denominator. So in this case, our radical is square root of 5. So the shortcut method is the radical number in the denominator, in the numerator negative 1. So we have now square root of 5 times negative 1, that is equal to negative square root of 5. Then what will happen to the denominator? So whatever the radicand, when we say radicand, that is the number inside the radical symbol, just copy it and put it in the denominator. 5. So that is why we need to copy now the 5 and put it in the denominator. So we have now negative square root of 5 over 5, as we are going to see rationalize now the denominator of negative 1 over square root of 5. So as we are going to finalize now, sine theta is equal to negative 2 square root of 5 over 5. For the cosine theta, that is equal to negative square root of 5 over 5. For tangent theta, that is equal to 2. For the cosecant theta, that is equal to negative square root of 5 over 2. For secant theta, that is equal to negative square root of 5. And for cotangent theta, that is equal to 1/2. Example number 3. An angle theta is in standard position with its terminal side in the third quadrant in the Cartesian coordinate plane. Find the 5 trigonometric functions if sine theta is equal to negative 3/5. Okay, so the solution. So we all know that the trigonometric ratio for the sine theta is equal to y over r. Then sine theta is equal to negative 3/5. Then we are going to assign now the negative to the numerator because we all know that radius or r is always positive. So we can say that sine theta is equal to negative 3 over 5. Then we're going to let now unknown for the x. Then y is equal to negative 3. Then for the r, that is equal to 5. So let us now solve for the x. Using the Pythagorean theorem, so we have x squared plus y squared is equal to r squared. So substituting the value for the y, which is negative 3, and the value for the r, which is equal to 5. So the equation now becomes x squared plus negative 3 squared is equal to 5 squared. So simplifying further, we have x squared plus 9 is equal to 25. So all we need to do is we have to transpose now positive 9 on the other side of the equation, and take note, when we are going to transpose terms from one side to another side, we are going to change the sign of the term from positive to negative or from negative to positive. So as we're going to transpose na positive 9, it becomes negative 9. So we have now x squared is equal to 25 minus 9. So as we're going to subtract now 25 by 9, so we have x squared is equal to 16. So as we are going to extract square root both sides, so we have now x is equal to positive negative 4. So we have two values for x. We have now x is equal to 4 and x is equal to negative 4. But one of these values we are going to get. And take note, as we are going to review the coordinate signs in the Cartesian coordinate plane. So we have here quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Each quadrant has a coordinate sign, and also in the x-axis and the y-axis. When a certain point lies in the first quadrant, x and y are all positive. But if it is in the second quadrant, x is negative, y is positive. But if it is in third quadrant, x is negative and y is negative. But in fourth quadrant, x is positive, y is negative. For the x and the y axis, so if it is in the right side of the point of the origin, so we have now x coordinate x and 0. It means that x is positive and the y is 0. If it is in the upper portion of the y, so we have now a coordinate of 0 and y. In the left side of the x-axis, so we have now negative x and 0. So where x is negative and y is 0 for the lower part of the y-axis. So the coordinate is 0 and negative y. It means that x is 0, y is negative. The problem says that the terminal side of an angle theta lies in the third quadrant. Means that in third quadrant, x is negative and y is negative. Then we are going to choose x is equal to negative 4. So let us now substitute the values for the x, which is negative 4, and the value for the y, which is negative 3, and the value for the r, which is equal to 5, to the 6 trigonometric functions. So these are the 6 trigonometric function ratios. So sine theta is given negative 3/5. For the cosine, x is negative 4, r is 5. For the tangent theta, substitute the value for the y and the x. Y is negative 3 and x is negative 4. For the cosecant theta, r over y. Substitute the value for the r, which is 5, and y is equal to negative 3. For the secant theta, substitute the value for the r, which is 5, x is equal to negative 4. And for the cotangent theta, x is negative 4, y is negative 3. So as we are going to simplify now, negative 4 divided by 5 is equal to negative 4/5. Negative 3 divided by negative 4, that is equal to 3/4. 5 divided by negative 3, that is equal to negative 5/3. 5 divided by negative 4, that is equal to negative 5/4. And negative 4 divided by negative 3 is equal to 4/3. So to sum up, sine theta is equal to negative 3/5. Cosine theta is equal to negative 4/5. Tan theta is equal to 3/4. Cosecant theta is equal to negative 5/3. Secant theta is equal to negative 5/4. And the cotangent theta is equal to 4/3. Example number 4. An angle theta is in standard position with its terminal side in the third quadrant in the Cartesian coordinate plane. Find the other 5 trigonometric functions if tan theta is equal to square root of 3. So solution, we all know that the trigonometric functions of tangent theta is equal to y over x. And the given is tan theta is equal to square root of 3. But we need to change this square root of 3 into ratio, square root of 3 over 1. Okay? But take note that the terminal side of the angle theta lies in third quadrant. If we're going to recall back, the x and the y in the third quadrant are negative. So means that x is negative and y is negative. Originally, the tangent theta in third quadrant is negative square root of 3 over negative 1. So we are going to let now x be negative 1 and y be equal to negative square root of 3, and we are going to solve for the r. Using the Pythagorean theorem, so x squared plus y squared is equal to r squared, we are going to substitute now the value for the y, which is equal to negative square root of 3, and the x, which is equal to negative 1. So the equation becomes negative 1 square plus negative square root of 3 square is equal to r squared. So simplifying further, the square of negative 1, that is equal to positive 1. And the square of negative square root of 3, that is equal to 3. Then we can say 1 plus 3 is equal to r squared. So to simplify further, r squared is equal to 4. And we have to extract square root both sides to omit the exponent of the r. So we have now r is equal to 2. Take note that r is always positive. So then let us now substitute the value for the x, which is equal to negative 1, y is equal to negative square root of 3, and the r, which is equal to 2, to our 6 trigonometric function ratios. So the given is the square root of 3 for the tangent. So as we are going to substitute the value for the y, which is equal to negative square root of 3, and the value for the r, which is equal to 2. So we have now negative square root of 3 over 2. For the cosine, the value of x is negative 1, and the value for r is equal to 2. For the cosecant theta, the value for r is 2, and the value for y is negative square root of 3. For secant theta, r is 2, x is negative 1. For the cotangent theta, x is negative 1 and y is equal to negative square root of 3. So let us now simplify further. So negative square root of 3 divided by 2, that is equal to negative square root of 3 over 2. Negative 1 divided by 2, that is equal to negative 1 half. Then 2 divided by negative square root of 3, that is negative 2 square root of 3. But take note that the denominator is a radical. So we're going to rationalize the denominator now. So we're going to use the shortcut method. So all we need to do, this square root of 3 in the denominator must be multiplied in the numerator too. So we have now 2 times square root of 3. Then we are going to copy the radicand inside the radical symbol, which is the 3. As we are going to rationalize negative 2 over square root of 3, it becomes negative 2 square root of 3 over 3. For the secant theta, so 2 divided by negative 1, that is equal to negative 2. For the cotangent, remember that negative divided by negative is positive. So as we are going to simplify, that is 1 over square root of 3. And we have to rationalize the denominator. So shortcut method, the radical square root of 3 must be multiplied to 1, that is equal to square root of 3. So 1 times square root of 3 is equal to square root of 3. And then the radicand in the radical must be copied and put it in the denominator. So as we are going to rationalize 1 over square root of 3, that is equal to square root of 3 over 3. So to finalize now, sine theta is equal to negative square root of 3 over 2. Cosine theta is equal to negative 1 half. Tangent theta, which is the given, which is square root of 3. Cosecant theta is equal to negative 2 square root of 3 over 3. For the secant theta is equal to negative 2. And for the cotangent theta is equal to square root of 3 over 3.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.